All right, so practice test problem number 15. The functions f and g are differentiable. So as soon as you see differentiable, you should say because f and g are differentiable, f and g are continuous. Okay, the table below, oh, it says for all values x. The table below gives values of the functions and their derivatives, has selected values of x with a being a constant. It says if h of x equals the sine of f of x, write an equation of the line tangent. We want an equation of a tangent line. So what two things do we need to do? Find to get an equation of a tangent line. What two things do we find to get an equation of a tangent line? You don't know that yet. That's scary because we have done this all year and we're going to keep doing it. So we need a point and a slope. So we want to get, and it says to h. So I need to find the point. So I need to find the y value that goes for h when I plug 1 in. So that is going to be the sine of f of 1. So my point, I come over here, there's f of 1 is 3 pi over 4. So that means I'm going to have the sine of 3 pi over 4. And so I'm on my unit circle. 3 pi over 4 is right here where my ordered pairs are negative 1 over radical 2 and 1 over radical 2. Or if you want to put negative radical 2 over 2 and radical 2 over 2, that's great. So the sine is the y value. So this value right here is 1 over radical 2. So that means my point, the point, is 1 and 1 over radical 2. If you want to make it radical 2 over 2, that's great. No biggie. Now I need the slope, so I have to find what else? The derivative. I need the slope. So h prime of x is going to equal, now I have to come up here and I have to do chain rule. So the outside part is this sine right here. So the derivative of sine is cosine. And I leave the inside part the same. Then I go inside here and I do the derivative of the inside. So the derivative of f of x is f prime of x. And I go inside and do the derivative of x, which is 1, which changes nothing. So now I'm supposed to be finding this derivative when x is 1. So I got to plug a 1 in here. I need to plug a 1 in here. And I need to plug a 1 in here. And I'm just going to get rid of this part because 1 times anything is anything. So I go f of 1. So here's f of 1 is 3 pi over 4. So this is the cosine of 3 pi over 4. And then f prime of 1, there's f prime of 1 is radical 2. So this is going to be times radical 2. So I go to cosine again, that's the same ordered pair, 3 pi over 4, but it's the first term, the x value. So in here I'm going to put negative 1 over radical 2, and that's times radical 2, and I hope we know those both reduce out. So this whole slope is negative 1, so my slope is negative 1. So I'm going to write the equation of my tangent line. So I'm going to get y minus y1. Well, y1 is 1 over radical 2. Is going to equal, and the slope we just found was negative 1 over here. And then it's x minus, and I come up here and it was x minus 1. So there is the equation of my tangent line. Does anybody else have anything they need me to do? Yeah.
B and C of that same problem.
Oh, okay. I'm going to write. I don't know if we're going to need this. Let me look here. Okay, so we're going to come down here and do, that's the answer. We're going to get that out of the way so we can do these other two. All right, so if r of x equals 1 over the square root of g of 2 of x, find r prime of x at x equals 2. So what I want to do first is I want to rewrite this without a radical. So that's going to be 1 over g of 2 of x to the half power. And because 1 is a constant, not a variable, if it's a variable, I do quotient rule. But I don't want to do quotient rule because it's a waste of time, because when I do the derivative of 1, it's going to be a 0. So it's faster if I take the denominator and move it up to the top by making its exponent negative. So this is still r of x. So now I want to find the derivative of this. So I'm going to get r, oops, started right f, r prime of x, and I'm going to do chain rule. So I start with the outside, which is the negative half. So I get negative a half goes to the front, leave the inside the same, subtract 1 from the power. Then I go and do the derivative of the inside. The derivative of g of x is g prime of x, and the derivative of x is 1, so I don't need anything. Now I'm supposed to find this value when x is 2, so I stick a 2 here, I stick a 2 here, and I stick a 2 here, and then I'm going to go up to my chart. So when I go up to my chart, I still have this negative a half, and I want g of 2. Well, g is right here, 2 is there, that's a value of 3, so this is going to be a 3 here. G prime of 2, there's g prime, go over here to 2, it's negative 4, so I'm going to stick negative 4 in here. So I would first say negative times negative is positive. This 4 and this 2 reduce this 4 to 2, so this will be 6. So that would be the answer for part B. Yeah. Ah! I made a mistake. We got to go back. My bad. Thank you for catching that. I screwed up because I left off the exponent. Okay, so let's get this back. So this thing right here is still negative 3 over 2. So this 2 is going to stay on the top, and then I move this 3 down here to the bottom, and that's good enough for your answer. We could rewrite that as 2 over the square root of 27 if you wish. 3 to the third is 27, the square root's that. But you don't have to. Okay? Thank you. So this should have been the answer right here. Thanks for saving me. Find the value or values of A if tangent lines to f of g of x and g of f of x are perpendicular. All right, so we need to find tangent lines that are perpendicular. Does anybody remember from geometry what there were about perpendicular lines? Opposite reciprocal is what? What are opposite reciprocals on perpendicular lines? The slopes. So we got to find the slopes of both these. So let's find the slope of both these. Find the value. Okay, so we want to find the slope of this. What's the word for slope in this class? Derivative. So I'm going to find the derivative of this. So when I find the derivative of this, you start on the outside part, leave the inside the same, times the derivative of the inside part. So that's the derivative of this one. The derivative of that one is going to be the same. Derivative of the outside part, leave the inside part the same, times the derivative of the inside part. Now this says we want to find values of A so that they are perpendicular. So when x is 3, so I need to come in here and put a 3 in and a 3 in, and I got to come over here and put a 3 in and a 3 in. So I go up to my chart. Now I get f prime, and I'm going to look for g of 3. I'm going to move this up a little bit. So g of 3 is 4, so I stick a 4 here. G prime of 3 is a half, so I stick a half here. And I need f prime of 4. So f prime is here, of 4 is 2a squared. So that means this derivative is a squared. So the slope of this f of g of x is a squared. That's the slope of it everywhere. Now I'm going to come over here and do this one. So I'm going to do g prime of f of 3. So I come up here to f of 3 is 1. And then f prime of 3, I go to f prime of 3, it is 5. And then I do g prime of 1, so g prime is here, of 1 is 1 over a. Oops, not equals times 5. So that means the derivative of g of f of x is 5 over a. Now, we want these to be perpendicular, right? So to be perpendicular, what do we know about a squared and 5 over a? They have to be what? Reciprocals, opposite reciprocals. So my question is, what is the opposite reciprocal of this? What would the opposite reciprocal of 5 over a be? Isn't it negative a over 5? Would that be the opposite reciprocal right there? Y'all see it? So that means that a squared has to equal negative a over 5. This has to be the opposite reciprocal of that. So a squared has to equal negative a over 5. So we want to solve this. So I got to multiply 5 over. So I get 5a squared equals negative a. Now the reason I know this is I got an a squared, so I have to solve this by factoring. So we have to get this polynomial equal to 0. So I got to add an a over. And now I factor out my GCF. And then I take both of my factors and set them equal to 0. So when a is negative 1/5, or when a is 0, those should be opposite reciprocals. So let's check this out. If a is 0, isn't this a 0 slope? And if a is 0 over here, isn't this an undefined slope? What kind of graph, what kind of a line is undefined? Vertical. What kind of line has 0? Are those perpendicular? Heck yeah. All right, let's do this other one. If I take negative 1/5 and square it, then I think a squared, maybe I should have put a squared up here. A squared is going to be 1/25, isn't it? And if I come over here, if a is negative 1/5 here, and I plug that in, I believe that this is 5 over negative 1/5. And if I flip that negative 1/5 upside down, I believe that's going to be negative 25. Are those opposite reciprocals? Heck yeah, we are in business. Questions? Anything else we want? Okay, I'm going to shut this puppy off.